coordinate geometry. Let us move on to section formula for internal division. So if point P x comma y divides the line segment joining points A x1 y1 and B x2 y2 internally in the ratio m is to n, then let us see what happens. So suppose there is a segment and this segment is say segment AB, or you can say let us consider a point on segment AB like this. So let this point be point P, and if this point P divides segment AB internally, that is inside in the ratio m is to n, then this x is given by mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. Now first of all, there are 3 points. You can see here this segment AB, the two endpoints are A and B. Now suppose if the coordinates of this point A are x1 y1 and coordinates of point B are x2 y2, and if the coordinate of this point P is x comma y, then we get this x is equal to mx2 plus nx1 upon m plus n and y is equal to my2 plus ny1 upon m plus n. We'll get to know this when we'll solve some of the examples based on this. So let us see the first example. What you're supposed to do is just remember the two formulas. These are the two formulas to find out the values of x and y. Let us consider an example. So here is an example. Find the coordinates of point which divide the line segment joining the points having coordinates -1, 7 and 4, minus 3 internally in the ratio 2 is to 3. So we have these 2 points. The first point is -1, 7 and second point is 4, 3. Let me first plot these 2 points. Say this is the first point over here. Let this point be point A, and we have one more point. Suppose this point is say point B. So we have 2 points, points A and B. So after joining these 2 points, we get a line segment. So suppose this is the line segment AB. And we have one more point, and that point lies on AB. Let that point be point P. And suppose this point P divides segment AB internally in the ratio 2 is to 3. The ratio is 2 is to 3. And the first point, which we have assumed as A, this A point has coordinates -1, 7 and B has coordinates 4, minus 3. So this first point A will have coordinates -1, 7. This point B has coordinates 4, minus 3. And we have a point P in between. Let the coordinate of this point P be x, y. We know that we assume the coordinates of first point as x1, y1. So quite obviously, we'll assume the coordinates of point A as our x1, y1. And we will assume the coordinate of this point B as x2, y2. So you can see here, let us move on to the solution now. So let A x1, y1 and B x2, y2 be the points having coordinates -1, 7 and 4, minus 3. And let P be the point x, y which divides the line segment AB internally in the ratio 2 is to 3. So we know the formula that x is equal to mx2 plus nx1 upon m plus n. Now we have all the values, that is we have the value of x1 is equal to 1, y1 is equal to 7, x2 is equal to 4, y2 is equal to -3. And we also have m is to n. So m here is 2 and n here is 3. So we do have the values of m and n. We will just substitute. So m x2 plus n x1, that is 2 into 4 plus 3 into -1 upon m plus n, that is 2 plus 3. So 2 4s are 8 and 3 into -1 is -3. So you'll get 8 minus 3 upon 5, which is 5 upon 5, and that gives us 1. So we got the value of x, that is the value of x is 1. Similarly, we have the formula for y. Y is equal to my2 plus ny1 upon m plus n. Again, we can substitute the values, that is 2 into -3 plus 3 into 7 upon 2 plus 3. So 2 into minus 3 is minus 6 and 3 into 7 is 21. So minus 6 plus 21 upon 5, that is 15 upon 5, and 15 upon 5 is 3. So we got the value of y as well. The value of x is 1 and the value of y is 3. So ultimately we got the coordinate of this point P, x comma y, that is this P, x comma y is going to be 1 comma 3 because x is 1 and y is 3. So the coordinate of this point P is 1 comma 3. Now let us move on to section formula for external division. So for that, if point P x comma y divides the line segment joining points A x1 y1 and B x2 y2 externally in the ratio m is to n, then let us see what happens. So let me consider 2 points. Now this point is A, the final point is P, and in between A and P you'll have a point B.